All right, guys, now we're going to talk about protein hydrolysis, which means we're going to break apart these proteins into their individual amino acids. It's pretty simple, all right? So here we have isoleucine, glycine, and phenylalanine, all right? So here's our structure. I drew it. Here's our Zwitter ion form. We get H3N plus down here and our COO minus down here. We got to add 3 waters. The number of waters you add is going to be dependent upon the number of um, uh, amino acids you have. Once we throw these 3 waters at it, what we'll get is isoleucine, we will get glycine, and we get phenylalanine. So it just breaks them apart. The leukoencephalin, here I wrote out the structure here, plus 5 waters. We then bust it up into our amino acids, and that's it. And that's what it means to be hydrolyzed. There are 2 others that I put here that if you feel the need to do these, you may. It's pretty simple though. Uh, this idea of the hydrolysis of proteins, this is your very first step in digestion. And we're going to get to digestion later. That's going to be part of our metabolism section. And so we've got to remember that this is essentially what happens. One of the things about proteins is you can get denaturation. What you do here is you end up altering the shape of the protein without breaking the amide bonds. And so this happens in a lot of different ways. One of the ways you could talk about this is like cooking an egg. An egg's mostly protein, and when you heat it up, you get a denaturation of the protein, so it changes shape. And in doing so, we permanently change the structure. It's considered a chemical change because, as you guys know, once you cook an egg, you can't get it back raw. So you've permanently changed the structure. You can do this in a lot of different ways. You can have high temperatures, like with the eggs. You can use acids. If for some particular reason you have a strong acid, like battery acid, in a couple eggs, you can cook the egg with the acid. It can happen with strong bases, and it can actually happen with physical agitation, anything that disrupts the peptide organization. And I say physical agitation because you can whip milk or cream, and as you keep whipping it, you're changing the peptide organization, and you're changing what you have. So you can have cream that's liquid, and if you whip it enough, you change that protein configuration, and you get whipped cream. So that's something that can happen here.